Namaste students, welcome back to my channel. Today in this video we will talk about the oxoacids of the sulfur, that how many oxoacids are present of the sulfur and what are the different structures of those oxoacids of the sulfur, and I'll give you a trick with the help of which you can easily calculate the oxidation state of the sulfur in each and every oxoacid of the sulfur by simply looking the structure of that oxoacids of the sulfur within less than 1 minute. So without any delay, let's get started. So before the starting of the main topic, first of all we have to know the meaning of the oxoacid. In our previous videos in the nitrogen family, we have studied about the oxoacids of the phosphorus, and in that also we have studied about the meaning of the oxoacids. So quickly revise the meaning of the oxoacid. That oxoacids are the compounds which shows the acidic property, which has the tendency to release hydrogen in the form of H positive ion, but the removable hydrogen is attached with the oxygen. In these substances, the removable hydrogen is attached with the oxygen. Therefore, these are known as oxoacids. So, oxoacids are the compounds in which we have hydrogen which is removable, and that hydrogen is attached with the oxygen. So, we have a number of oxoacids of the sulfur, and in this video we will study that how we can calculate the oxidation state of a sulfur with the help of the structure of the oxoacid. And for that I'll give you a trick which you will apply in any oxoacid to get the oxidation state of the central atom. So we'll start with the simplest oxoacid, that is, first one is H2SO3. H2SO3. This is the simplest oxoacid of the sulfur, and the name of this oxoacid is sulfurous acid. This is sulfurous acid. Now first of all, we'll draw the structure of the sulfurous acid, and with the help of the structure, we'll calculate the oxidation state of the sulfur. The general oxidation state, how to calculate the general oxidation state, I hope you all know. If you don't know, then I'll tell you that method also. Now, the structure is S with a lone pair, double bonded O, single bond OH, and single bond OH. And because of the presence of these two hydrogen which are attached with the oxygen, this is known as oxoacid of sulfur. So this is the structure of H2SO3, that is sulfuric acid. Now, if I have to calculate the oxidation state of the sulfur by the general method, how I'll calculate the oxidation state of Hb plus 1. Why it is plus 1? Because it is attached with a non-metal. When hydrogen is attached with a non-metal, its oxidation state becomes plus 1, and when hydrogen is attached with a metal, its oxidation state becomes minus 1. So here hydrogen is attached with a non-metal, therefore its oxidation state becomes plus 1. So in this case, 2 into plus 1. Why 2? Because here I have 2 hydrogen, plus let the oxidation state of sulfur be X, plus 3 into minus 2. Minus 2 is the oxidation state of the oxygen, is equals to 0. Why it is 0? Because overall charge in this compound is 0. So through this, if I calculate 2 plus X minus 6, that is equals to 0. X minus 4, that is equals to 0, and X equals to plus 4. One method is this, with the help of which we can calculate the oxidation state of the sulfur. Now the other method, from a diagram how we calculate the oxidation state of any element, then I have to calculate the oxidation state of the sulfur. I have to calculate the oxidation of the sulfur. Now whenever I have to calculate the oxidation state of the central atom in the oxoacid, I count the number of the shared electron. First of all, I count the number of the shared electron. Now this sulfur has shared 1, 2, 3, 4 electrons. This sulfur has shared 4 electrons because 2 electrons are present as a lone pair. These two are not shared by the sulfur. 1, 2, 3 and 4 electrons are shared by the sulfur. Now next I'll see that to which element these electrons are shared. To which element these electrons are shared. Now here the electron are shared with oxygen. Here also the electron is shared with oxygen and here also the electron is shared with oxygen. Means in all 4 bonds, sulfur has shared its electron with the oxygen. Sulfur has shared its electron with the oxygen. Now we know that the oxygen is more electronegative as compared to sulfur. And if the electrons are present between the sulfur and the oxygen, due to more electronegativity, oxygen try to attract the electron, shared pair of electron towards itself. As a result of which there is a decrease in the electron charge density around the sulfur atom. Clear what I am saying? First of all, I will see the number of the shared electrons. Sulfur has shared 4 electrons. Next I will see that to whom the electrons are shared by the sulfur. To oxygen. Here oxygen, here oxygen, here oxygen. Now we know that the oxygen is more electronegative as compared to sulfur, as a result of which the electrons are attracted towards the oxygen, are attracted by the oxygen, as a result of which electron cloud around the sulfur becomes less, and electron cloud if less, then our oxidation state comes in positive. We know that oxidation state has a charge, either it is positive or it is negative or it is zero. So because in this case sulfur is attached with the oxygen, means the electron is shared by the sulfur and the oxygen is more electronegative than the sulfur. Therefore electrons are moved towards the oxygen, as a result of which in around the sulfur there is a lesser electron charge density, as a result of which its oxidation state becomes positive. How many positive? The number of the electrons shared by the sulfur, that much amount of positive. So the number of electrons shared are 4 and 4 electrons are shared towards the oxygen. Therefore the oxidation state of sulfur becomes +4. Clear? 1 electron by this oxygen, therefore +1. Second electron again by this oxygen, that's why +2. Third electron by this oxygen, that's why +3, and fourth by this one, that's why +4. So with the help of the structure, we can easily calculate the oxidation state of the sulfur. So in this, the oxidation state of the sulfur is +4. Either you can calculate by this method or you can calculate by this method. Now we'll move to our second member, that is H2SO4. The most common oxo acid of the sulfur, that is sulfuric acid. That is sulfuric acid. Now, if I draw the structure of the sulfuric acid, it becomes S, double bond O, single bond OH, single bond OH. Now, by looking at the structure, you can predict the oxidation state of oxygen here. By looking the structure. How? Sulfur. How many electrons are shared by the sulfur? 1, 2, 3, 4, 5, 6. Because 6 bonds are there. So 6 electrons are shared by the sulfur. So 1, 2, 3, 4, 5, 6. And in each bond, the sulfur is bonded with oxygen. That is the more electronegative element. And if it is more electronegative element, then the electron cloud move away from the sulfur, as a result of which its oxidation state becomes positive. But how much positive? The number of the electrons shared by the sulfur. How many electrons are shared by the sulfur? 1, 2, 3, 4, 5, 6. So the oxidation state of sulfur becomes +6. Its oxidation state becomes +6. And if you calculate by this method, then it becomes 2 multiplied by +1 plus x plus 4 multiplied by -2, that is equals to 0. 2 plus x minus 8, that is equals to 0. X minus 6, that is equals to 0. So x equals to plus 6. Clear? So with the help of this trick, by simply looking at this structure, we can easily calculate the oxidation state of the central atom. Just we have to know that to which element it is bonded, and out of the two elements which one is more electronegative. Now we'll move to our third oxo acid, that is H2SO5. That is H2SO5, which is known as peroxomonosulfuric acid. Peroxomonosulfuric acid. Now, if I draw the structure of this particular compound, then now why it is peroxomonosulfuric acid? Why it is peroxomonosulfuric acid? Because if I considered that all the oxygen are present in the form of the oxides, means if the oxidation state of all the oxygen is -2. Suppose if all the oxidation state of oxygen is -2, then if I calculate the oxidation state of sulfur, it becomes 2 plus x minus 10, that is equals to 0. X minus 8, that is equals to 0, and x equals to plus 8. But we know that in sulfur, plus 8 oxidation state is not possible. We know that in sulfur, the maximum covalency extend up to plus 6 due to the vacant d orbital, but not beyond plus 6. And here the oxidation state, if I consider that all the oxygen are present in the oxide form, then the sulfur oxidation state becomes plus 8. It means all the oxygen are not present in the oxide form. The oxygen are present in other form also, and that other form is peroxide. So if I draw the structure, that's why it is peroxo. That's why I have written here peroxo. So if I draw its structure, it becomes S double bond O, single bond OH, single bond O, OH. And because of this linkage, because of this peroxo linkage, it becomes peroxomonosulfuric acid. Now, if I calculate the oxidation state, of the sulfur, either by this method or by looking simply the trick we are using, by simply looking the structure. Here, sulfur is surrounded by 6 bond. It means sulfur has shared its 6 electron, and with oxygen, sulfur has shared its 6 electron. Therefore, its oxidation state becomes plus 6. Now, if I calculate the oxidation state by this method, hydrogen 2 into plus 1 plus x plus 3 oxygen are present in the form of the oxide, and 2 oxygens are present in the form of the peroxide. We know that in peroxide, the oxidation state of oxygen becomes -1. So 3 into -2, because 3 are present in the form of the simple oxide, plus 2 into -1, and 2 are present in the form of the peroxide. That is equals to 0. Now 2 plus x minus 6 minus 8 minus 2, that is equals to 0. Minus 2 plus 2 cancel, and here x becomes plus 6. So the oxidation state of sulfur becomes plus 6. So either with the help of this method or by simply looking at the structure, we can easily calculate the oxidation state of the sulfur. Now we'll move to our next oxo acid of the sulfur, that is H2S2O3. That is H2S2O3, thiosulfuric acid. we know that whenever we replace a double bonded oxygen by a double bonded sulfur, we'll place this word, that is thio or thio. So it is thiosulfuric acid. Means in this compound, this is a sulfuric acid, but in sulfuric acid, one of the double bonded oxygen is replaced by double bonded sulfur. So the structure becomes S, double bond S, single bond O, single bond OH, single bond OH. So here is our sulfuric acid, this is our thiosulfuric acid. Double bonded oxygen, single bond OH, single bond OH, single bond, double bond O and double bond S. Now, in this case, if you calculate the oxidation state of the sulfur by this method, so all the oxygen are present in the form of the oxide. So if I calculate by the previous method, then it becomes 2 multiplied by 1 plus 2 into X plus 3 into minus 2, that is equals to 0. 2 plus 2x minus 6, that is equals to 0. So 2x minus 4, that is equals to 0, and x equals to plus 2. X equals to plus 2. But in this case, x equals to plus 2 means according to this method, both the sulfur have plus 2 oxidation state. But actually, both the sulfur do not have plus 2 oxidation state. So what is this plus 2 oxidation state? In this case, when we have two atoms of a particular, two atoms of a particular element, then in that case, by this method, we get a general oxidation state. We get a general oxidation state, but not a specific oxidation state. So with the help of the diagram, we can easily calculate the particular oxidation state. Now, let us consider this sulfur as 1 and this sulfur as 2. Now, in this case, this sulfur has SP2 hybridization. In this case, this sulfur has SP2 hybridization and this sulfur has SP3 hybridization. This sulfur has SP3 hybridization. In our 11th class, we have studied that more the S character, more will be the penetration power. Penetration power means the effective nuclear charge experienced by any subshell of a particular shell. We know that if we have S, P, D and F subshell of a particular shell, then S has the most penetration effect because it is at a minimum distance from the nucleus as compared to the P, D and F of the same shell. So more penetration power means more effective nuclear charge. More effective nuclear charge means more electronegativity. So if we compare a bond of SP, SP2 and SP3, then out of these three, SP bond is the most electronegative bond because this bond contains most S character, that is 50% S character. In SP2 and SP3, S character decreases whereas P character increases. So due to the decrease in the S character, its electronegativity also decreases. So here we have two sulfur. Out of these two sulfur, this sulfur has sp2 character, whereas this sulfur has sp3 character. So sp2 is more electronegative as compared to sp3. Therefore, means s1 is more electronegative as compared to s2. So electron will move towards s1. So as a result of which, this sulfur becomes positive and this sulfur becomes negative. First thing is this. Now second thing, in this sulfur, how many electrons are shared by this sulfur? 2 electrons. And this sulfur is attracting the electron towards itself. And how many electron is attracted by this sulfur? 2. These two are of this 2 sulfur atom. That's why the oxidation state becomes -2. Why -2? Because this sulfur is more electronegative than this one. And this is attracting 2 sulfur which is shared by the sulfur 2. That's why its oxidation state becomes -2. But if we talk about this sulfur, its oxidation state becomes +6. Why? Because the number of electrons shared are 1, 2, 3, 4, 5, 6. And in this, 3 are oxygen, which are more electronegative than sulfur. That's why 1, 2, 3, 4 plus 4. And this oxygen is also more electronegative than this oxygen. That's why it is also plus 2. That's why the oxidation state becomes plus 6. So with the help of this structure, we can easily calculate the oxidation state of the sulfur. Now we'll move to our next oxoacid, that is H2S2O6. That is H2S2O6. Now I'll draw the diagram. I'll draw the diagram of H2S2O6 and you tell me that what is the oxidation state of sulfur. H2S2O6. Clear? If I draw the diagram, it becomes double bonded O, OH, OH, double bonded O. And the name of this is dithionic acid. This is dithionic acid. This is dithionic acid. Now in this case, both the sulfur has same electronegativity, because in both the sulfur have same environment, that this is surrounded by 2 double bonded oxygen, this one is also, this is surrounded by 1 OH, this one is also. So for both the sulfur we will consider plus 1 plus 1. Now if I calculate the oxidation state of this sulfur, now this sulfur has shared 1, 2, 3, 4, 5, 6 electrons. 6 electrons, 3 oxygen. So it becomes 1, 2, 3, 4, 5, that is plus 5, because oxygen is more electronegative, and here sulfur, that is plus 6. So the oxidation state of both the sulfur becomes plus 6. The oxidation state of both the sulfur becomes plus 6. With the help of this, we can easily calculate. Now if I calculate with the normal method, it becomes 2 plus 2x minus 12, that is equals to 0. 2x minus 10, that is equals to 0. 2x equals to 10 and x equals to plus 5. So plus 5 is the general oxidation state of H2S2O6, but the oxidation state of both the sulfur in dithionic acid is plus 6. It is plus 6. And with the help of the structure, we can easily calculate the structure. Oxidation state. Now, sixth one, that is H2S2O7. That is H2S2O7, which is pyrosulfuric acid. Now its structure become SOS, double bonded O, double bonded O, double bonded O, OH, OH, double bonded O. Clear? And because of this linkage, it is pyro. So in this case also, both the sulfur has same environment. So the oxidation state of both the sulfur remain same. So if I calculate the oxidation state of first sulfur, the oxidation of second sulfur is also the same. So in this sulfur, if I talk about this sulfur has shared its 6 electrons, and with the oxygen. And since oxygen is more electronegative than the sulfur, therefore its oxidation state becomes plus 6. And similarly, the oxidation state of this sulfur is also becomes plus 6. So it's a simplest trick with the help of which you can easily calculate the oxidation state of the central atom with the help of the structure of that particular compound. Now I'll give you the last oxoacid structure and you tell me that what is the oxidation state of sulfur in that particular oxoacid. So our last oxoacid is H2S2O8, that is peroxo disulfuric acid. This is the name of this particular oxoacid, and the structure of this oxoacid is O, O, S, double bonded O, double bonded O, OH, double bonded O, double bonded O, OH. Now, one hint I'll give you that the oxidation state of both the sulfur is same because the environment of both the sulfur is same. Both the sulfur are attached with the equal number of the atoms and with the equal number of the bonds. So this is the homework for you, that you have to tell me that what is the oxidation state of sulfur in this particular compound by looking only the structure. And if the concept is clear to you, it's my belief that you can calculate the oxidation state of sulfur in this case by simply looking the structure of this particular compound. So I'm waiting for your answer. That's all for today. I'll see you in my next video with a new topic.